You've heard a little bit about what RavenPack does, and so very fast. We process every day over 100,000 documents. We do this in real time with a very low latency. We publish structured data on the unstructured data within about 250 milliseconds. We run in the Amazon cloud 24/7. It's always up. And you probably think of and have heard about RavenPack as a great data vendor. And I want to say that we also aspire, especially in my team, that we be a world-class software company as well. So I want to go a little bit behind the scenes and tell you about that. How do we do it? Well, there's a modern architecture. Someone was actually asking me, how did you ever navigate so smoothly to move to the cloud in the last 5 years? Our architecture was always distributed. That means that we had different pieces running on different pieces of software running on different pieces of hardware from the start. And multi-threaded. That means your computers, which have lots of cores in it, we can take advantage of that. This is different from some sort of monolithic software. When then you move to the cloud, all you're doing is running it instead of on your computer on someone else's. Right now, instead of running on our set of computers, which was limited, we can run on Amazon's set of computers, which for many intents and purposes is kind of unlimited. So migrating to the cloud was easier for us than for many of our potential competitors and in the software industry. And now with the cloud, we also have horizontal scaling, which means as we add more data or we have more subscribers to that data, we can easily get more computers on board, and basically everyone has the same level of service. Today, I want to talk more specifically about event detection. So at RavenPack, we identify all sorts of events. There's thousands of event types. I think we're nearly 7,000 at this point. There's a lot in equities related to companies, which you can see here. And there's also lots of global events. And in the future, we can expand into events on sports or whatever. The technology is very agnostic about this, but the expertise of the company is clearly much more towards finance. Right? So some of our event detection features, when we talk about an event, what does that mean? It means we identify which entities participate in the event. I think Peter talked about entities earlier. There's certainly companies, but also people, products, commodities. All of these things are what we call entities. Right? Not only do we identify that they're in an event, but what role do they play? In lawsuit events, it's really important to know who's the plaintiff, who's the defendant, merger and acquisition, similarly. Ratings, who's the rater, who's being rated. Clearly, these make a difference. In addition to the entities, we also have other attributes of an event, like dates, magnitude, sentiment, and trust. Trust is about, is it a factual event or an opinion event? And finally, we have event consolidation. That is, in any document, a news story, the headline might contain, hey, earnings up. Later in it, you might find that earnings are up for which quarter, by how much, things like this. These are all the same events. We take these little parts, and we don't publish 5 events for the same story. We publish one event based on the best aggregation of the data that's there. Okay? All of this gives valuable data, more actionable. So an event type is composed of multiple roles, and we'll see examples in a second. And each role allows for a particular type of data. And we have a matching engine, which when it matches the text, is able to pull the data out of the text and put it into the appropriate role of the event type. This will be important in a few slides. Right? As well, there's conditions which define a match. And I'll explain that. I think it's on the next slide. All right. Unfortunately, this is small. Don't worry. These are 2 different examples, and I'll tell you what's there. The top one is a legal event, and basically, vertically, there are roles. One of the roles is plaintiff, one is defendant. Then there's the date of the legal action. There's positions there about, in other words, is this legal action against a CEO or a CFO, things like that. A variety of roles. The second one is earnings up. And this one has a condition, which again, you're not going to be able to see, but 2 of the fields for earnings up are the actual earnings and the previous earnings. And for this event to match, actual has to be greater than previous, which of course is obvious, but if you think textually, the pattern or how you would match this is exactly the same for earnings down. right? You still have some company announced some earnings and some previous earnings. You don't know if it's up or down until you actually extract the numbers, look at them, and make that determination, right? So that's how RavenPack does that, okay? Sorry about the formatting here. But the classifier is a piece of technology at RavenPack which does something. And today we're talking about event detection. There's also one for entities, things that I mentioned before. The event detection classifier, though, is fundamentally taking some template, which is kind of like a regular expression, some pattern of text, and matching it against the story body, but we annotate that body. Particularly, it's annotated with entity detections and as well with attributes. And an important thing that we'll see in a couple of slides is that the same text can be annotated in multiple ways, right? It'll be more clear with an example. First, some of the templates. These are how we describe event types. So you can see the first one, company declares bankruptcy. That would be a bankruptcy type of event. Then something like the United States forecasts unemployment down. Could be a headline that might match something like that. Consumer confidence goes up for a certain period. Companies' ratings were raised from one rating to another rating. And a lawsuit example, where you can see that you have two different companies and they're going to land in different roles, and we have to make sure we get that right. Here we have annotated text. On the top, there's a headline, which is in green, or a sentence. And you can see, like, for example, we have declares. And declares can be a way of saying announces. It can be a way of saying declares. It can be a way of, what is the third one there? Saying testifies, right? So the same particular text is annotated in lots of different ways because we might have a template that makes more sense to write in one way or another, okay? And the bottom example you see as well, like to decline is a negative thing. It's also falling. It could be rejection, things like that. Lots of different ways. So we start with the text, we annotate it, and then we can match it with the patterns. Right? So this is what we're doing nowadays here. The template engine matches annotated text with these templates, okay? Again, I'm sorry the formatting got a little goofed up there. But an important thing is multiple templates can match the same set of text, and then there can be a scoring algorithm to either allow multiple to win, to say this text really is multiple things, or to choose one to be the winner. Sometimes something that looks like earnings up might be better stated as earnings above expectations. That's a more impactful event. Right. The algorithm that does this is like a Reedy algorithm. Some of you might be familiar with that, and it allows simultaneous matching of lots and lots of patterns against a chunk of text. And here's a really quick view of how things are organized. The important thing to notice here, besides the bad formatting, is that in order to do a match, it doesn't matter how deep this tree is from top to bottom, how much data is there. The time in order to do a match is only how far left to right you have to go. Everything is like a hash table lookup. Anyways, if you want to know the details, please talk to me later. All right, so what are we doing now to make this even better and make the computer do a lot more? We're augmenting existing matches to produce what I'm calling enriched events. So when we do a match right now, we might not fill all the roles, but there might be information nearby where that match was that we can fill in. So like the dates, magnitudes, sentiment. All right, so let's see. Okay, here's an example sentence and something that matches. Company buyback, some number of shares. And you can see that that sentence will match. The company repurchases so many shares. But when we run it through our system now, we also get this bolded aspect, which basically is capturing this first part. In the first quarter of 2018, that was not part of what the original engine matched, but it looked and said, hey, this event type has a date in it. Is there a date nearby? And that's where the types that I mentioned earlier come into play. It's never going to fill in a magnitude into a date role, for example. Here's an example where we found some date information, wasn't part of our match, and put it in there. Here we have another example about consumer confidence in Mexico. You can see this template is going to match, and it is capturing a bunch of information. But there's this thing at the very end, on monthly basis. And we actually have what we call a method for that. Is this a monthly, quarterly, year-on-year, last versus last type of event? And that matters because Mexico might have two events announced at the same time, one of them being up and one being down, but one of them is comparing months, one's comparing quarters. The more information we enrich the event with, the more impactful it can be to use. And a final example about a company entering some sort of business agreement. You can see that this headline qualifies as a business agreement. And now we have this wildcard in the middle, and we're able to grab Tuesday as the date when this business transaction actually occurred, which is, again, correct and is giving you a lot more information about the event than was there from what the original engine did. Okay? So moving beyond this, what we actually want to do when we introduce brand new event types in future products is start to describe the event in terms of just a small set of essential items, which we're calling a theme, and then run this augmentation on it. What this is going to allow us to do is have the computer do more work and have humans do less work. Right now, there's a human aspect to writing the templates. And we want to have the humans provide a lot of energy and insight as to what constitutes this event without having to worry about the myriad ways that it might be expressed in a news story. And we think this themes approach has a lot of legs, and what we've done with augmenting our existing things is proving out the technology. A lot of this should be available in a product from RavenPack probably next year. Beyond that, we know we want to use machine learning. This has been a goal of mine forever, is that I really just want a human to say, this sentence or this paragraph is this event type, and have the computer do all of the rest. And if you just state that, it seems, even to me, pretty hard. But these steps that we're taking, starting with a nice matching engine, augmenting it, talking about just describe things in themes, pretty soon we have enough themes and we can have the computer learn this is what a theme is. So I'm pretty optimistic about the future, and this has been a long-term plan. And I mean, the main thing to take away is that the technology behind RavenPack that's producing the data that Peter's writing research about and you guys are taking advantage of that shows value, it's evolving and constantly getting better. The next version should have much more data about all of the events and allow us to produce more types of events more rapidly because we're using more technology to do this and less human intervention. And I hope that was 10 minutes.
This is RavenPack.